So I know some of you know C because some of you are in my office. I don't know your various levels of C, so we have to start from the very beginning. We'll ramp up as quickly as sort of a whole group can do that. So we're not really going to do Hello World all 3 hours. But I don't. I'm sorry, I don't know where to start. Anyone never done C before? You don't have any. Just raise your high so I can see. You don't know C. You're not telling the truth. It's for OS. Well, all right. Any C experts, like I don't know, 8 out of 10 or above.
C expert.
Yeah.
I consider myself some.
Well, it shouldn't be there, but you're still welcome to stay. All right, so what I'm going to do then is use a forceful teaching style, which means essentially you can't have any of these things electronically. You have to type them. Because if you're learning C, you don't learn C by taking examples and just glancing at them, compiling in them, and then running them. You need to have some of the syntax stick in your brain, and so some of the time tonight, most of the time, 60% of the time, I'm just going to be showing you examples, but there's going to be some exercises you have to work on, and in that case, you'll have to actually do something. All right, so starting, some of the printouts for whatever reason are missing Hello World, the very first one, and you can always tell what these are by just reading the ASCII art at the top. So this is hello.c. If you're missing this page, don't worry. I'm the printer hates you, but I don't. So I would say that this is a great skeleton to start with when you're starting a C program completely from scratch. And it's so useful that I actually have a Emacs macro that when I just go into a editor in class or something and do programming in C, I just do that and I get bling the skeleton. Get used to using this as a basic skeleton because it'll keep you out of trouble and start you along the correct path. So, I mean, technically you can write C programs that look, with like naked mains without argc and stuff, but it's not that much extra effort to just do it the correct modern way. And if you want to make a macro so that you can just plop this into your editor right away, or just make a file and copy it every time you make a start. Does that make sense? Okay, so use that as a basic skeleton. When you run this, you see hello, and I'll just move on. So I have some basic list of the order that we're going to look at things in. We look at basic.c. That's flip forward one sheet there. There's a bunch of variable initializations, conditionals, while loops, for loops, and stuff. And again, if you have any familiarity with C, this will be boring to you, but we're going to ramp up pretty rapidly into something that's more fun. But have a look at basic.c. Flip through. It should be very close to the top of your file, probably right after hello. Have a look at this as I'm talking and just make sure it all makes sense to you. And if something doesn't make sense, then say so. So I have the main that looks exactly like the main in the hello world, and I'm going to talk in a minute about what argc and argv are in the following example. I have 2 integer variables here, one initialized to 5, a is 5, and I not initialized to anything. Okay, don't assume default initialization values in C for any variables that are local to a function. So you're going to get random values for I. Try to use I, you get some random value. It's probably not predictable what it would be. We'll talk about this a bit later, but an exception to that is global variables in C are always initialized to 0 by default. So pointers, and if you don't know what that is, we'll talk about it soon. Pointers get 0 values, integers get 0 values, floating point things get 0 values. Everything gets 0 values automatically if it's global, but local variables don't get any rational value unless you explicitly initialize. Okay. So I didn't explicitly initialize I because I'm going to use it as a loop index later, but A is set to 5. Okay, here's a very, very simple function call where I'm passing the character A, so single characters are in single quotes in C. Strings of one or more characters are in double quotes. Don't confuse those. As we'll see in a while, a single quoted character is a small integer. It's the integral ASCII value of the character, the lowercase character A. And so I could even take like the A that's in quotes here and like add 5 to it and get the character that's 5 positions along. If I have something like this in double quotes, that's a character string or a string in C. It's radically different. We'll come back to that later. So you'll have to get used to not confusing those things. A single quote, a single character in single quotes is not the same as a single character in double quotes. They're very, very different. You see negative integers, floating point numbers, and so forth. These are all being passed to this function called do something, and you see that the argument list here, a character that's a single printable character, a signed integer, right? A long, which is a bigger integer, a long, which is a bigger, even bigger integer, a float, which is a relatively low precision floating point number, double, which is a high precision floating point number, and then unsigned versions of these, meaning they cannot take on negative values. These are all the parameters, and you should always make sure, of course, that the types of the things that you're passing in here match the types of the things that are being passed in here. Largely, C will help you not pass incorrect typed arguments, but the thing you should get used to immediately in C is that it's very, very seatbelt free. So there are going to be many, many, many cases where you can do literally whatever you want. You'll get no compiler error, and you'll get a horrible crash because you've done something bad. So Java, Python, more modern non-systems programming languages, you do something bad, make a horrible mistake, you usually get at least a compiler message, right? Compiler warning or error message. And when you run the program, if something horrible happens, like say you have an array with 5 elements in it, and you look at the 17th element, you get a crash with a meaningful error message. In C, you'll get a segmentation fault, which means you cause memory corruption, and you get nothing else besides that. So you might wonder, why on earth am I writing? Why do I want to learn some language that allows me to make horrible and mysterious errors that make me rip my hair out? The reason is that the seatbelts being off are what creates the amazing performance that C has. So you should think of it as essentially being like one step above assembler language. And all modern operating systems are written in C. The Java compiler and the Java JIT compiler and the Java interpreter that runs when you type Java and that's written in C. Python's written in C. Ruby's written in C. Everything's written in C. So that's the reason. So you can hate C, but you can't in your lifetime escape the fact that it's the most prevalent systems programming. So I'm not advocating, if you don't want to learn C, that's fine, but I think you do because you're here. You're just motivating why you might want to. So I happen to love C, but even if you don't love it, you're relatively stuck with it because in terms of low-level systems programming, it's pervasive. In the future, the people that like Rust would like Rust or some other language to take over. That's not going to happen immediately. So it's not like, oh my God, I went to Golden's boot camp. What a waste of time because tomorrow everything's going to be written in Rust. Operating system code bases now are 50 million lines plus each of C, Linux, Mac OS, and Windows. So there's literally zero chance of that being written in Rust in like a year or 2 years or 5 years. So yeah, try to like it at least for the next couple of hours. All right, so this function call does nothing except call printf. Printf is the print formatted. It's the easiest way of generating formatted output in C. So these things that you see after percent signs here, %C, %B, percent LD, percent LLD, percent F, percent U, percent LU, percent LLU. These are type specifiers that indicate what the type of the arguments that are coming out here. So printf is a varied function, which means that variable number of arguments are allowed, and you have to pass the same number of arguments here as you have percent signs in here. If you don't do that, then you either generate cool exploits or you cause memory corruption and get either weird values or terrible crashes. So I think you're only 4 minutes into this, and you see that the parent, I tell people this, and they sort of like, you're showing off. You have to write C thoughtfully and don't make any mistakes. I don't mean that like on my, Golden's Uber God and C, he doesn't make mistakes. I make plenty of mistakes, but I have tons of experience, and I'm cautious of how much pain I'm going to pay if I just like blob some C down while watching a cat video and then have to debug it later. So it requires thoughtful planning and careful programming. So pay attention to what you're doing, and you'll gradually, build up enough experience that you're just going to sort of self-check yourself as you go to make sure you're not running off the bounds of an array. So in Java, honestly, you can do lazy programming. You write something and you didn't get the array length correct, you get this cool error message that tells you that you did that, you go and fix it. In C, you run off the end of the array and end up changing other variable values, and your hair stands on end and everything goes crazy, okay? So just be thoughtful and try to write it correctly the first time instead of just blobbing something down and hoping that it works. Because the other shocker is that you can write C programs that work correctly. I literally run it 1,000 times and it will run correctly, and run it 1,001st time, maybe on a different architecture, and it doesn't work correctly because it's wrong. You just lucked out, and the memory corruption that you've caused hasn't done enough damage to make it die before. But when you're doing the demo for your boss, it's or the spaceship is finally launched, right, and comes crashing down because the 1,001st time doesn't work. It's bad. All right. Any questions about that? Okay. So the original motivations for all these seatbelts being off are that, honestly, some of the best programmers on Earth wrote C around 1970 and didn't need seatbelts, right? I mean, they won like Turing Awards for being literally some of the best programmers that the Earth has ever seen. So they didn't want any seatbelts. And also, they were trying to write a systems programming language that would run fast enough that they could write operating systems in it. And so C was written so that Unix could be written, essentially. That's the reason they've always been kind of tied together. Does that make sense? All right, so we're just ripping through very simple conditionals and stuff, and I hope you're not asleep. There's more fun stuff to come. I'm going to also point out some gotchas in here. Equality checks in C require 2 equal signs. A single equal sign is assignment, and one of the reasons other languages do things like maybe this is a check for equality and something like this is an assignment is to prevent you from confusing them. C, there's no such seatbelt, and so if I say this, I mean assign the value 0, and if I say this, I mean check to see if A has the value 0, and if I think I'm doing this and leave out one of these, I'm assigning A 0 and then seeing if that's a non-zero value in the conditional. So the assignment will still happen. A will be set to 0, and then the conditional will fail because 0 is false in C. So 0 is false, anything else is true. So this is a very common mistake when you're coming from languages that do equality checks using a single equal sign. This is a case where you have to be careful, right? Because if this is something like this instead, and you accidentally do this, then you're assigning A5 every time, instead of just checking to see if it's 5. Does that make sense? Anyone want to leave? Do you want to leave?
Like, if you just said A, would you say what?
Yeah, so conditionals in C, when you have something inside of here, right?
Yeah.
The thing that's in here is evaluated, and all C is interested in is it 0 or non-zero? 0 is false, non-zero is true. Any non-zero is true and zero is false. So yes, so if you did, if A was in fact zero and I did this, you get a true value. And if A is not zero and I did this, I get a false value because I've just assigned A zero. And then it's checked, then the value is checked. So everything inside the parens is evaluated, and then the result is checked to see, is it zero or non-zero? Zero is always false. Anything besides zero is always true. So experienced C programmers actually will do things like this, but I'll tell you that there's going to be no harm and no one's going to laugh at you. Just stop doing assignments inside of conditionals and then checking results. It's better to do the assignment separately and then check it, because it's very, very error prone. Right. If I want to set C to, if I want to set A to something and then check it, just do it out here and then check A there. Like, don't mix them together. That makes sense. So we'll see this in a while, but like a common thing that's done is you have, when you're opening files, you'll see something like this. So essentially, if FP is non-zero, the file open worked, and if FP is zero, the file open failed, because F open returns zero on a failure to open the file. So I've actually done the assignment and the check in a single swoop here. But you can separate these easily, as I'll show you later, and make a stay out of trouble. When you're a super C programmer, then you start, doing things that you can do things that are more dangerous. So yeah, so if you're coming from Python, you have braces in C. Braces are not required in certain circumstances. Always use braces. Don't ever not use braces. This is the reason why. You have some conditional like this, right? If I use braces, as many statements as I put here, those are all, you can see Emacs, telling me it's true. Everything inside of here is subject to this conditional. If you don't use braces, this thing is subject to the conditional, and none of these are. It's the first and only statement. This thing is inside the conditional, and these are not. And if you want to make a Python programmer crazy, wait till they go get coffee and then just go mess with all the indentation, and it breaks all the logic in the program. And you can have whatever opinion you like about that. I think it's not great. It's not a great thing. It looks pretty, maybe, because you don't have all these braces polluting everything. But in a C program, if you use braces, just forget that you don't have to use them. If you use braces, there's absolutely nothing you can do with indentation in C to mess C programs up, which is kind of awesome. So this is valid. This is valid, right? So everything can be on one line, right? This is perfectly valid. If you don't use braces, then you're gonna get yourself in trouble. Does that make sense? Okay. There's really no benefit at all to not using braces, because you're gonna have to use them most of the time anyway. In the special cases where you don't need them, you don't use the special cases. Okay, so I'm getting rid of all this here. Yeah, so if statements are pretty straightforward, they look just like other languages. I don't think that's very controversial. While loops, same rules for every time there are conditionals in C. It's zero is false. Anything else is true, right? So essentially, Boolean values are just integers in C. Zero is false. Anything else is true. That's kind of cool because you can do addition on things and then check the value of some variable just by saying something like if A. You're basically checking to see if A is zero or not. You don't have to explicitly have two equal signs. So there's a top tested loop that looks like this. There's a bottom tested loop that looks like a do while like this. You can use it whichever one meets your criteria. And then the for loop looks like an initialization. This happens one time. This is checked at the top of the loop every time. And this, whatever is here, it's usually like an increment or a decrement of the index. This happens at the bottom of the loop. Okay, so top of the loop one time, every time at the top of the loop. If the condition is not true, the loop doesn't get entered. This is a bottom of the loop statement, and you can chain things together here if you want, like like you could increment two things there, but generally you're going to increment only one thing. This condition can be arbitrarily complex. It doesn't have to only depend on I, but right, and it's again 0 is false and anything else is true. Any questions about this very simple stuff? I know you're snoring slightly, but it'll get better. Oh, all right. So how many people have not seen switch statements in C? Never seen switch statements. Okay. So switches are case statements in other languages. It's called a switch statement, and the cases actually use the case keyword. They're more flexible than they are in other languages, and I'll show you why in a second. But the basic syntax is I switch on some has to be numeric value. So if you're used to being able to do case statements based on strings and things like that, it doesn't work in C. This has to be a numeric value, and these are a bunch of possibilities. If 0 is true, you print A is 0. If 1 is true, if 5 is true, and then there's a default one. This is a keyword. If there's a default, meaning none of those, I get this one. Does that make sense? Now, importantly, you don't see any braces in here. See braces on the outside of the switch. That's on purpose. The break statement means execute this, and then the switch statement is over. If I remove the break, you get a cascade into the next condition, and you keep going until you see a break. So in this case, if the value of A is 0, I'm going to see A is 0 and A is 1, and then a break. So the first matching case is all that matters. If you don't have a break, you'll cascade through any remaining ones until I hit a break, execute all the code until I see that. That's another case of know what you're doing, right? If you're half asleep and forget breaks in there, you're going to get very weird behavior, right? And this actually, this has a purpose, right? So imagine that in the 5 case, I'm actually interested in not just the case 5, but all these cases. I could do something like this, where I'm interested in all those cases, right? And the idea is that if it's 5, it cascades through until it sees a break. If it's 6, it cascades through until it sees a break. If it's 7, it cascades through until it sees a break. If it's none of those, you skip the whole thing. Does that make sense? Mm-hmm. So the breaks are really important. If you don't put the breaks, you get all the cases from the matching one all the way down to the if I take all the breaks out and A is 0, I'll see A is 0, A is 1, A is 5, and A is neither 0 nor 1 nor 5, which is weird, right? Any questions about that? Yes.
If A is 5, does it evaluate like case 0 and 1, or does it skip straight to 5?
So the compiler is smart, of course, and there's some magic happening under the hood. These don't have to be in any particular order. It's the first matching one that matters. So if A is 5, 0 and 1 don't execute, only 5 execute.
So it still compares it though, right?
Yes, yes, there's still a comparison. It only stops comparing after a matching case, and then you start cascading through until you find a break. Does that make sense? Mm-hmm. Is this all right? Mm-hmm. Okay. How many people have used ternary operators in C? Some of you in the OS class have. How many people have never seen ternary operator? You don't know what I'm talking about. No one? Really? Before I was second. Huh? Before I was second. Oh, okay, that's fair. So I think ternary operators are better explained with like an example as I showed you. So you might have an if statement that looks like this. If A equals 5, then set I to 7, else set I to 9. Ternary operator works this way. It says some variable is equal to, I ask a question, A equals 5, question mark, that means I'm asking a question. If true, the result is 7, colon, the other alternative. So this in a one-liner does the same thing as this big if statement. So you're saying essentially, if A is 5, question mark, the answer will be 7, otherwise it's 59. And these can be nested and can be much more complicated, but just, sort of easier way into using those. Any questions about this? And here's something here's something a tiny bit more complex that's using the ternary operator. I said A is, and then there's a %s, that's a string, right? And then I'm checking here, not A, that means if A is 0. If A is 0, the string 0 will be used, and that'll substitute here, right? Right? Otherwise, is A 1, 1, if A is 5, 5, or neither 0, 1. So I've nested a ternary operator there and avoided like a big conditional, and I've supplied 1 to 4 different strings very quickly. Does that make sense? So I think it's pretty straightforward. You're asking, the question is even built in using the question. Any questions at all about this very basic stuff? Okay, more fun stuff. Command line stuff. So we can, feel free to run these if you want. So like, where all of these work. Here's command line.c. So roll forward 1 page. This won't take long. This is what the argc and argv do in C. It's very frequently the case that C programs, because they're often used to create command line utilities, will need to process command line arguments. Argc is a count of the number of command line arguments, which is always at least 1. Why? Because the name of the program that you're running is the first argument. So a C program can self-check its own executable name using this. Okay. So argc is a count, and this thing is a one-dimensional array of strings. And we're going to look at strings in a bit, but for now, just imagine that it's an array containing first command line argument, second command line argument, and so forth. And so a popular way of cruising through these is to use a for loop that starts at 0 and goes up to, but not including argc. So arrays in C are always indexed from 0 and then increments each time. And I'm using puts here. That puts a string with no formatting. And just looking at argv of I. So I'm looking at argv of 0, argv of 1, argv of 2. So when I run this, if I run it by itself, the single command line argument is the name of the program I ran, which is a cool way of figuring out what the command line looked like there, what I ran, what my name is. Right? If I do stuff like this, if you don't want things to be broken along with spaces, you have to use quotes around them. So the command line arguments look like that. And similarly, if I want to, if I don't have quotes, then those are 2 different. Any questions? Okay, so I think it gets more fun now. Tell me if I'm wrong. There's some functions at the top that we'll come back to in a minute. But let's, this is more like what real C programs look like. Crazy stuff. I have a variable A and it's set to 7, and I have a variable B and it's set to 3, and I have a pointer to an integer variable C that's set to the address of B, which means C is pointing at the memory that was used to hold the value 3 for B. So interestingly, now we've created aliasing where I can use C to influence the value of B without changing B. You'll see this in a minute, and we'll come back to this, guys. C lets you directly manipulate the bytes that make up variable values. So you can actually interrogate memory addresses, do copies and stuff like that. So a really crazy way of assigning the value of A to B is to use mem_cpy, mem copy. This says look at the memory address where B is stored, that's the ampersand. And look at the memory address where A is stored and copy as many bytes as there are in the size of an integer, which on this machine is 4 bytes. So mem_cpy address of B, address of A does a low-level byte by byte transfer of all the bytes of A into the bytes of B. Now, there's no reason to do this when you just say B equals A, but there are going to be use cases for something like this in your C future. Does this make sense? And you can do that with any type, like structs and everything. So we're probably going to have to talk about pointers, and I may have to use the board. You're just going to have to ask me questions of this is free, and you know why did you come if you don't care about learning stuff, right? This is, I told you this is a pointer. The star C is being used to point at the box where B the value of B lives. I'm dereferencing the pointer here and saying, look inside the box that C is pointing at. That's the value of B, and change it to 9. So when I do star C equals 9, B is changed. B is changed to 9. That may look weird, but that's actually also how you pass variables by reference and not by value. It's a necessary thing to be able to do that. And you shouldn't gratuitously use it like I'm using it here, because you can imagine writing something where you're aliasing all kinds of things and changing things without explicit initialization, and you'll forget you did it, and like, well, hey, why is B changing? And you can set up nightmarish C programs that will, confound someone for days, but generally that's a bad thing for software. Does that make sense? Okay, so this is very disturbing, perhaps. Right? I'm setting C of 0 to be 13. Well, what does that do? Well, technically, the pointer C is an array of integers, and it just happens to be pointing at only a single integer, B. So by setting C of 0, the 0th element of the C array, I'm changing B to 13.
So if you were to put C1, would that be one size byte like ahead?
C of 1 would be 4 bytes beyond B on the stack, and you probably going to start that. This is really the subject of the course 4362, software exploitation, but these are declared on the stack in increasing order like this, like I'm going up. So changes to C beyond the single element that it actually points at, we're going to start destroying these variable values. So you'll see spontaneous changes in other variables that don't make any sense to you until you think about the fact that you've only got an array with one element in it, and you're trashing other memory. And then you can actually trash the return address of main on the stack and cause arbitrary code execution. It's all kinds of stuff that'll happen. And I would suggest only doing that when you want to explicitly do it and know what you're doing. So C will not stop you from doing this. But that's 40 bytes from the start of where B's value lives. And whatever is there is going to get destroyed and over into 30.
Would that be a cycle?
You're not necessarily going to get a seg fault until you wander into memory that you don't own. So if you're wandering around in your own variables here and trashing them, you get no errors whatsoever. That makes sense. You don't have to like it. You just have to acknowledge that it is the way it is, and it's never going to change because C's fundamentally not able to do array bounds checking.
If you change it to C10, it's 40 because the size band is 4 bytes.
Yeah.
right? So you're-
Yeah, so think of B as, I'll just draw a picture here, just ASCII marks. B is a 4-byte integer, and basically B is the name that's attached to these 4 bytes of memory where the value goes, right? C is this pointery thing that can be pointed at something, right? And so when we're causing the alias to happen, what we're really doing is figuring out this operator, the addressive operator, is pointing C at the place where he lives, and that's why you're referencing C with something like 13 instead of writing. We'll write it here, and I'll tell you why in a minute. Ends up writing like 13. Right? So similarly, A is a 4-byte integer, and what memcopy does is a byte by byte transfer of this A into B. Right? It's a byte by byte transfer of each byte of A into the bytes of B, which causes an override of B, and these values keep the exact one. And if the constraint for the memcopy was size of int, that's what gives me the 4 bytes. I just happen to know on the Mac it's 4 bytes, but if you go onto a different machine, that you really need to use size up to know exactly what. Yeah. So it's just a byte. It's a low-level memory copy. It's okay. So I think for now, there's some uses in exploitation of using offsets here that are not legitimate. I'm not going to sort of delve into that because we have so much legitimacy. I'll just say that until you know what you're doing, don't do those things.
I was a little bit curious, is that what like a stack canary is supposed to protect?
So stack canaries are placed to either between arguments or near the return address to stop this. It's to cause a signal rather than a arbitrary override. Any questions about this so far? So you see that here I've aliased C to point at where B lives. Here I've changed the aliasing now to the point where A lives. The reason I'm doing this in this example is to point out why, in general, if you don't know what you're doing or if you don't need to do this aliasing stuff, you should minimize it. Because you may think, well, sure, if I change C, I'm going to end up changing B because I see this. But then somewhere else in the program, the alias has changed. Now changing, dereferencing C starts changing A. And if you expand this to like hundreds or thousands of variables, you're not going to keep track of it carefully. Does that make sense? So the ampersand is getting the address of A, so I'm initializing C. When I do this, I'm not initializing C, I'm actually changing the value that C points at. So the star C looks in the box and writes something into B. But the explicit initialization of C is actually changing where that pointer is pointing. So the pointer that's pointing at B here ends up pointing here. This link is broken. It's there. And then star C will change the bytes inside of A. Okay, so it's starting to get a little more interesting. I know Hello World's like, oh my god, really? There's lots more crazy to go. You can just stay with it. Yeah. If you see, so when I create a pointer variable like C and point it at something, we're going to look at some other ways of pointing at something too. All pointers are arrays. So that you're going to see that those are equivalent concepts in C. Every pointer is an array. If it's just pointing at a single variable, though, it's an array of length 1 that's pointing at a single element. Now, but you had a different, I'm just clarifying that, you had a different angle. What was it? So I think you're hinting at something that we're gonna look at. When I do, this is never better picture. So here's P, right? And there's the 4 bytes that make up P. And when I say C equals ampersand B, right, I pointed C at the very first byte. Now, interestingly, in C, if I in the C language, not the C. If I this is not C++, this is increment C. C equals C plus 1. If I increment C, the increment goes here. So you skip to the next element because C is an array. C is not an integer. It's a pointer to an integer. So when I do any arithmetic on it, there's a built-in magic invisible factor of how big is the type that I'm pointing at. So this is cool because it means you can rip through arrays by using increment. You can increment the array value actually to move array.
So, when you declare those initial A, B, and C, they're on the stack,
Yes.
and so, there's pad, like, B is 4 bytes long, but then you have C, but there's like a little bit of padding in between.
It's not likely on the stack that these are actually next.
Yeah, and so,
This one is actually, C is 8 bytes long on this machine.
okay,
A and B are 4 bytes long.
why is C 8 bytes?
C is 8 bytes long because C is a pointer on a 64-bit machine, which needs to be able to address any memory address in a 64-bit address space.
Okay, so like A, it would be like A 4 bytes, some padding, B 4 bytes, some padding, and then C 8 bytes. And also,
I would say that on the stack, though, C is the lowest address.
okay,
It goes this way.
okay, what determines that? Is there like something that determines the amount of
Yeah,
padding?
if people wonder, like, how far apart is the memory associated with these variables? You should just assume that you don't know. So you can always take the address of it and print it out. Like I can add a printf here that when I run it, will show you the memory addresses of these things. That's a legitimate thing, but the padding is decided by the individual compiler you're running.
Oh, okay.
So it's not going to be possible to predict that stuff. But let's just add that and then I don't think I'll just show you. So you can print the addresses of these guys. And %p pointer is the way of doing that. That's going to give you a hexadecimal address, memory address of where that thing lives. So we'll just do this, right? And then when we do this, you need to take address of A, address of B, and address of C. Even though C is a pointer, you're interested in where C lives, not with the value of C.
If you did just C, it would have the same address as either A or B.
Yeah. So if you do this, like C's value is this, and C's address is this, and then do these two things.
Yeah.
The cool thing is you're going to see that the third one is equal to the address of B. As you point. Okay, so let's just run that. You can see. Yeah, C of 0 is also B value, and star C is B value. Yeah. So when we run this, you see that yeah, they're not that far apart. You see that C's value is 18. That's B, same memory address, and where C actually lives is nearby. So you see that this is the lowest address, then B, then A. It goes this way up.
That's great.
So the way that we could think about this compiler, actually reading our codes is it starts at the bottom, and like whatever variable it is, you just place that on the center.
Yep. Yeah, that's the most simplistic way. The interesting thing is that because of exploitation stuff, compilers are starting to randomize the locations of these guys so that exploits won't work correctly. So we can't predict anymore what order they're in. So we really want programs to work, not for exploits to work. Unless you're doing nation state warfare. I think that you want the exploitations to work, you know.
What about the printout? So, like, it said C and B are the same memory address, but what is like the memory address of the pointer, not the memory address of what the pointer is pointing to?
Yeah, yeah, that's the final value that's here. That's the one that's here, took the address.
Oh, okay. Oh,
Yes,
okay.
when you ran this, you saw that C's addresses. So
Oh,
you can really look at like this, and then the one over
Uh-huh.
here are all pretty adjacent. Yeah, this one is just B's address because it's alias. All right, does this make sense? What else is in? Okay, now we're gonna do something you can't do in Java. We're gonna have a peek at A. So I used a char pointer here. That's a 1-byte integer, a char, C-H-A-R. And I'll tell you why I used a 1-byter in a minute, but I have peek, right? And what I did is set peek to be the address of A. Now I'm walking the memory bytes that make up A and looking at them individually. So A is a 4-byte integer. Peek is a pointer to a 1-byte integer. So I'm walking from 0 to size of A, which is 4, which is a 4-byte integer, peeking at the individual bytes of A and printing them out as hexadecimal digits.
Okay.
So you probably want to see that probably here. Peeking at the individual bytes of A looks like this. Peek text. A, B, C, D.
Isn't it 14?
6,
14. Because we started.
E is 50.
F is 15.
Sorry, F is 50.
Yes,
E
so
is
E is
14.
14.
E is 14. Yes. All right, so the first thing you notice is I walk the bytes, right, from left to right, and the bytes are in disorder with zeros at the bottom. That's because this machine is Little Indian, meaning integers are stored in backward byte order. That's true on Intel boxes too. All these Windows boxes you're using it's all Little Indian architectures. That's because computer engineers can design hardware that's faster by storing integers in backwards order. So you're stuck with it whether you like it. And if you go into a calculator and you type 3, you have to read it this way as a human. 3E7 is 999. Yes.
what machines are big?
So MIPS machines have an option to be a big Indian. MIPS processors are used in things like the cheaper routers, cheaper network routers. Most of the more expensive ones are using ARM. And there's old mainframes and stuff that are big Indian, but Little Indian is the popular choice now because it can be made more efficient. This is a reason to take computer architecture. All right, so yeah, so that's cool, right? So I looked at individual bytes. Anyone know why I used char star instead of a int star? Why is Pete? Let me just do this so you can see it. Here are the variables. Why did I use an unsigned char star instead of an int star?
Because if you use the n star and you incremented it, you would pass it inside.
Yeah, if you use an int star and you increment, it goes forward by 4 bytes at a time. I'm trying to look at each individual byte, so I need a pointer that when it's incremented only moves forward 1 byte.
Why would you use an unsigned character?
Char is a signed integer that has values -128 to +127. That's because there's only 127 printable ASCII characters. Yeah. Unsigned char is just used when you're going to output hex, typically from 00 to FF.
Why do you have to do P equals like this?
It's because the type of key sorry, the type of A is
Where you're setting that.
it's a cast, yeah. So the type of A is an integer, and we're not. If this was an integer pointer, you don't need the cast, but we're changing the type of the thing that points to it. Fun?
Yes.
Well, I'm glad, Ronald.
It looks very.
I hope it's catchy. All right. Importantly, single characters are single characters in single quotes. They're just ASCII values. So a char is actually a very tiny integer that can hold 1 byte worth of integer value. So when I put char 97, right, or put char A like this, those are exactly the same. You go look at an ASCII table, you'll see that the lowercase a is 97 in decimal. That's its position in the table. So those are equivalent. So if you wanted to print all the characters, you could literally start at 0 and just keep incrementing and put char in, and you'd see all of them. Make sense? It also means that if you have some character, you have some char C and it has some value, and you want to convert to say lowercase, all you have to do is subtract this and add lowercase a.
Oh yeah, that's one.
So you can just treat it numerically. Whatever the position of uppercase a is, you subtract that out and then add in lowercase a, and that's exactly the lowercase value of C. You'll eventually just memorize the important ones. Honestly, if you live long enough, then you should just go look at an ASCII table. And a char is an integer. So in a printf, you can actually use %b and look at the value. Does that make sense? Okay, and then before we move on to more interesting things, here's I showed you a function call where we're passing things by value, right? So I'm passing a by value to just look. But I need to be able to create functions that can change their arguments. If I'm going to do that, I need to pass the address of the thing so that I just split view this here. There were some functions at the top. Just looked like this, and I changed a to be 17. And when I print it here, I'll see that, but there's no change on the global thing. I'm sorry, on the a that's in main. Won't see any change. Here I'm passing by reference, right? So it's this one, and I have a pointer on this side, and I use indirection to dereference the thing, right? And say star b equals 37. That's actually going to change the value of the b that's out here, but not because I called this b. It's just because I'm actually changing what b is pointing at. And so it might be less confusing if you saw something like this, because I think you know about scope, right? So the scope of C is local here, the scope of B was local here, but I passed in the address of B, and so when I say star C equals 37, it actually changes. Any questions about that? So if you're just look at your paper maybe instead of this, and you can see what's happening here. So I passed in a was 999. Just look, the value of a was changed. The local a was changed, and just look to be 17, but there's no impact on the value a and b. Then I pass the address of b to change, and it changed to 37. You see the impact. So that's just parameter passing stuff. You're going to get used to using pointers all over the place in C. They're required.
Every single variable type and like functions, everything can be passed by parameters. Like if you want to change it globally.
No, so these are not global. So they're declared as main. If you declare the global things, you don't pass it all. It's reference different. Anyone want to read one? Donald? I don't know, man, maybe change your act.
10 years since, what, first month of freshman? No.
It's possible. All right, here's the depressing news, and this is the single thing that I don't like about this. There's a few things, but this is the most painful thing, and that's that C does not have a first class string type, meaning you can't declare something of type string and then add them together by saying like C equals B plus A, where A and B are strings, and we get a bigger C that's the concatenation of those. This doesn't exist, and so strings in C are character arrays. So they're potentially declared like this, right? So I have char buff of 512. That's an array of 512 characters, and the convention, and it's an important one, is that I always have to have a terminating zero byte, binary zero, called a null character at the end of the useful part of the string. If I don't do that, the string functions will cause memory corruption. So I don't actually have space for 512 characters here. I have usable characters. I have space for 512 characters in total, 511 plus one extra slot for the null terminator. That makes sense. And so you can't add strings together and stuff. You have to use functions. So I'm illustrating just a bunch of them here. So by setting the zeroth element of buff to 0, the string is empty now. It has no characters. It's the null terminator sitting in the first slot. I have to do that before I do this string cat. The string cat takes whatever's in buff and adds a high to it. And if it can't find the null terminator, you're going to get memory corruption.
You have to do the like slash 0. You don't.
Yep, this is binary 0. This is binary 0. This is binary 0 in octal. This is binary 0 in hex. I'm sorry, this is binary 0 in hex. Yeah, so yeah, just 0 is fine. You can also say null. That's also cool. That's 0 as well. There's lots of zeros. So I'm string padding in high, and I'm string padding in there, and now the buffer is high there.
So the string cat automatically move.
It null terminates so that the null terminator can be discovered. Okay. I can get the length of strings by using stringlen, and stringlen does not include the null terminator as you want. I can use SCCHR. There's a bunch of string functions. I can't possibly enumerate them all, or you'd all go to sleep. And there's more fun stuff that come anyway. But there's a bunch of string functions. strchr finds the location of the first occurrence of the lowercase t in buff and returns a pointer. So now this location is actually another string that's pointing at the t and all the characters after it. Now again, if I start changing location, if I change the string location, I'm changing a substring of buff. So I have aliasing happening here. So be careful about that.
There's no way of finding like the second character.
Yeah, if I want to find the second t, I can just take location, right? Imagine I want the next t like this, right? I can take location, sorry, CHR location plus 1 t. Because the first t is at location, and any other t would be after that. And if I don't find one, I get a null as the return value, which means there's no more t's. So the ability to fluidly do pointer arithmetic and stuff means you can do all kinds of stuff really fast without a bunch of extras.
So you said it picks up whatever's near t. So it picks up whatever's less than 3.
Yeah, because look, like the location is pointing at the t and then everything after onto the null terminator. So location plus 1 is pointing at whatever's after the t all the way up to the null.
So basically, so if you wanted to follow, like find like an integer number of it, then you just put in a loop.
Yeah, you need a loop that keeps moving past the last T that you. Now, there's also some strength parsing things where you don't have to do that may be a little bit easier, and I think there's an example. Yeah, so str searches for the first occurrence of string, not a single character, and returns that as a couple. So again, if you wanted to look for the next occurrence of location of there, you use the location +1, right? Does that make sense? Long unsigned. Where yeah, so string len return, strings can be huge, right? String len returns an unsigned long, that's how you return unsigned long. So long unsigned is what the element is. That's equivalent to literally this type. Also known occasionally as that type size T. That's internally defined as something. Okay, when you want to compare strings, you use strcmd, or you can write a for loop or something, but I wouldn't. I'm comparing buff to high there, and the return value is either negative, 0, or positive. And it doesn't matter what the negative value is or the positive value is. Basically, is the value that's returned less than 0, 0, or greater than 0? Less than 0 means S1 is less than S2. Right? 0 means they're the same. So you'll see experienced C programmers would do something like if not strcmp of A and B, then do something. That means if A and B are equal. It's a not means the 0 return value. Right? And if you're not checking, if you want to know if they're not just not equal, what you don't care about the order, you literally can just do this, because that means they're not equal. Now you may not love that because it feels kind of like this one should be the equality one, but it isn't. It's the 0 return value. That's equality. This is not equality. If occasionally your guts kind of twist a little, you know, Kernighan and Ritchie did all this in 1970, so it's too late. Too late. So this you see 2 free equals string dupe milk bread cheese coffee. Now 2 free and string are both pointing at a copy of milk bread cheese coffee. And now we're going to tokenize this string, meaning tear it into pieces using this delimiter. And the delimiter set can be bigger than just a single thing. You break on, say, spaces, tabs, and new lines, and commas, all kinds of stuff. It's just a simple example. So what string step does is returns a pointer to the next token in the string where comma is the delimiter. And if you call it repeatedly, you get all the tokens. So I'm going to get milk bread cheese coffee. Yeah. It's break on. Separate each character. No, you need to this has to be an actual character that it can find, or else you're going to get no match token. Yeah. So you need to like walk the string using a puzzle if you wanted to look at it here. And we're going to come to memory allocation in a bit, but you have when you use string dupe, you have to give the memory back that was provided by string dupe. So think of string dupe as making a box that's big enough to hold all the characters in the string you were duplicating. And that box is allocated, and you have to give the memory back or else you have a memory leak. Now, all memory leaks are corrected when C program exits, but if you have a long running program with a memory leak, you keep leaking, you'll exhaust all system memory and the program will crash. So if you're used to garbage collection, like in Java, where you just forget about them, you ignore objects and they just disappear, they never disappear in C. You have to explicitly disappear them. Okay.
Yeah, just book about K&R. Heard you say the original K&R book is like old C. What's the difference between like that and then?
So the modern standard has a bunch of stuff in it that isn't in K&R. So the old, the new C is better in every way. But so it's you know, it's not like some people took the C standard and ruined it. They've really worked hard to figure out how to make it a little bit more modern and a little bit less error-prone. And so modern C has lots of cool stuff that you couldn't do all the time. Yeah.
Can you explain a little bit more of the string separation? Separation?
String set.
Yeah.
Yeah, the way this works is you take it takes the address of string, right? And looks at the thing that string is pointing at and breaks it into component tokens based on a delimiter set. And here it's just comments. And so the idea is if you call it repeatedly using a pointer, right? This is a character pointer. It's here. Each time this string set returns, it'll be pointing at the next token in the string.
So if you were to call one time, just return milk or
Yeah,
pointer to
yeah.
milk.
Yes, and if you call it again, you get bread. You call it again, you get cheese. You call it again, you get coffee. You're supposed to check though, because you don't want to keep calling it when it didn't return something. Then you'll print out a null string and probably crash. Yeah.
Can you just explain again the buffer? So the buffer zero, you state between zero, so that the whole string is now empty. Like that?
Oh, and you mean here? You mean this thing?
Yes.
Yeah, so by moving, this is the null terminator. By putting the null terminator in the beginning position of the string is empty.
So the null zero is now.
It's empty, you know, and of course it's still 512 bytes long, but it's empty as far as the string functions are concerned. So if you run this thing, you can see it do some stuff. But we'll try to explain it. It is going to become more fun.
It is.
Much worse. I don't know. We'll see. Here I'm trying to illustrate, I'm not sure if I'm doing a good job or not, the correspondence between pointers and arrays. It's really important to get into your brain that pointers are arrays. Even if they're only pointing at one thing, they're pointing to an array of size 1, right? And just make that correspondence. And so here we have an integer array with 50 that has room for 50 integers. And we have a single integer. We'll see what that's used for in a minute. And then we have some more aliasing going on where I've made an integer pointer, ARR, and pointed it at nums. So now nums and ARR are pointing at the same block of memory. So now I'm initializing a random number generator based on the current time. You don't have to worry about how this works. This is a standard way of doing random number initialization. So if you just do this, then by calling this random function, you get random integers back, which is great, right? The time of null is a seed. It's seeding the random number generator based on the current time, so you don't get the same stream of numbers every time. So I'm using random to give star ARR a value. What is that? It's the first element of nums. It's a 0 element of nums. So I'm printing that out. I'm incrementing ARR. Now it points to the second element of not the two index, but 0, 1, the second human element. Right? And I'm printing out both here, I'm printing out, the value of I and the value of ARR. Look at your printout, let me run this, and you tell me if anything doesn't make sense. Oh, sorry, you did a free one right here. And just flip forward until you see AP.C at the top. Make sense? Taking a random number, and we're just looking at it from two angles, and both angles should be the same. I can use ARR or I can use nums.
So it's saying the C for this is the time of the machine.
So time of 0 is the number of seconds since 1970.
Okay.
Yeah. So it's different each time. So if I run this over and over, I'll get a different stream of random numbers. You just look at the last one and see that happen, right? Sometimes in C programs, you want the same stream of random numbers for debugging purposes. You can have a fixed C, like S random of 1 will always get the same stream of random.
I'm missing how they're.
Yep, that's because ARR is aliasing nums. So right now, ARR is pointing at nums of 0. So when I say star ARR, that's dereferencing the pointer and dropping the random number into nums of 0. When I increment here, that's nums of 1, nums of 2, nums of 3, nums of 4. And that's because ARR is incremented by 4 bytes every time. When I ARR plus, it's 4 bytes because the size of an integer is 4. So again, pointers and arrays are the same thing. Right? That makes sense.
I mean, is it supposed to be 500 and not 50?
Huh?
The I?
Oh, yeah, yeah, absolutely.
You have it on your hand, but that's 500 and too.
Yeah, well, it's not supposed to be possible. That's me fiddling with things, doing the wrong thing. That makes more sense because that seemed to be too much output. But yeah, curiously, that's just using stack space that I didn't ask for, right? And it works and it didn't crash. But if I'd made it 50,000, you definitely get a crash.
Speaking of trash.
You just.
What happened?
This computer has been working this week.
Oh, did it blink out?
Yeah.
Oh, okay. I don't think that had anything to do with this. But... Yeah, so you should have seen only like this. Good catch. Still works. The spaceship didn't crash.
So our files that we have, it's like this too, but they're not updated.
Right. That's perfect. Yeah.
Yeah.
Yeah, I had to do something more fun. There was some fun by me, so I tried to. Any questions about what you saw? Right. It's gonna get worse.
I have a question about the memory for the program. Is it like a set amount that the computer gives to the program before it starts, or like, for example, that 500 boot? Is it assigning memory as it
The
goes?
stack has a fixed size, and the stack can expand, but it should expand under circumstances that legitimately need it to expand. If I just ran that thing to like 5 million, I'm definitely going to run off the edge of the stack and have a second. Yeah.
We're you intending to give us two separate numbers here?
No.
They're supposed to be the thing.
Yeah. So look here. I'm looking at it from two different angles by giving you star ARR and nums of I. Those should be the same because I'm keeping them in sync on purpose. Does that make sense? And I'm not sure if this was clear from this example, maybe I blew it a little bit, but, if I have, let me just, this is not in here, this is just made up on the spot. So I have, imagine I have this, right? Okay. And it works. Imagine I have this, right? This is the 49th element of A, right? This is 49th element. Is that okay? Yeah. Then it's clear why. The reason it works is because when I add things to B, I get automatically a factor of 4, which pushes me forward in the array as it should.
You need to be right outside.
Yeah.
Well, I have a question. It's strange one. You don't pull it up,
Yeah.
but you said 2, 3 in stringable. So it's like no fractions, whatever. Then you 3, 2, 3. Why didn't you have 3 string?
Because they're both their alias. It's pointing at the same thing. Yeah. Yeah, there's only one called the string do. They're both pointing at the string do value. Yeah, and you saw then that you can do things like A equals B equals C equals, equals 5. That's all, everything's 5.
So,
Yeah. Yeah, basically things like this just result in everything being 5. Is this good so far? All right. I know this is still kind of basic. It's going to get less basic. Sorry. This is yeah. So here's some structures. Structures are boxes with elements inside. So think of them as like the non-object oriented version of objects. And so the C is not object oriented, and you don't have functions attached to data types. You have data types and you have functions, and they're separate. Right? So this is structs.c now. If you want to move forward, I have a couple of different types here. Person has an age and a name, and whether they're dead or not, 0 or 1. And we're going to leave unions aside for now. That can be some self-study, because I want to get to some more interesting stuff. And I have a favorite here that's color and a number, right? And so there's just some initializations in here that show you how to initialize some stuff. This is kind of interesting. So I have this person here, right? And it's an age and a number and this is a special kind of initialization. I have this global variable that I've made called global person. And I said, only this field, dot name equals Cecil. That one is initialized. Because this is global, age and dead automatically get initialized to 0, even though they're inside of a structure. So dead is 0, so not dead. Make sense? And age is 0. You know Cecil's not dead.
Yeah.
Yeah. All right. So and then I just gave you some initializations here to just show you how to do this. You basically declare variables of type, say, person or favored or whatever, and to initialize them, you just use dot notation. So s dot number equals 13. Blah blah blah. Any questions about structs? This is not a super interesting topic. You just need to know about them. Yeah.
So sometimes you see like a little underscore like at the top of the initialization. Does that matter, or is that just like distinguishing?
You saw an underscore.
No, not here, but I've seen it like
I
in code before.
You've seen something like this.
Yeah.
Yeah, this is because people are disturbed by the fact that the type that you see here and the type that you see here are the same. But you don't have to, and if you want to, it doesn't matter. But let's think about what these are. What the type def is doing is declaring a struct person and then giving it another name called person. So the two types that you're getting out of here are one type called struct person and one type called person. And these are completely distinct, and so if I put in the underscore, I have then a type called struct underscore person and a type called person.
Okay,
Because the struct is attached here, there's no way that these are ever they're never gonna be misunderstood.
okay, so you're not creating like two separate things whenever you don't.
No,
put the
you're
underscore.
creating one and
Yeah.
giving it an easier to use name than struct person. So type def didn't exist originally in C, and so everywhere I would have had to say struct person. That's annoying. So by aliasing this like this, I can say person instead of struct person. Any other questions, Bob? Don't be shy.
I have one. So you could say struct and anything, it doesn't have to be anything to do with person. You're just aliasing it to person.
Yeah, this can be like struct A. Now you have a type A and a struct A and a person. It's the same.
So if I'm understanding this correctly, if you didn't have type def, but you only had struct person, then every time that you tried to make a new person, you would have to type struct person.
Yeah,
Every
so
single-
I can do something like this. Now I have a type called struct another.
Hmm.
And every time I want to declare one of these, I have to say struct another E, struct another A. And that's old C.
Which is why I typed that.
Yeah, type def is awesome because no one wants to say struct everything.
You,
I'll just leave that actually.
Because you like type that and then change it to just the reference in the type.
Sorry. Structs are boring.
it's,
They're not really boring, but they're more fun things to look at. And when you just had it and want me to go away, it says, yeah, this is fun. People know how to do bit operations at C. Manipulate individual bits. Who's manipulated individual bits? Who's never manipulated individual bits at C? Anyone? All right. So this is worth looking at. This I think is going to just be a takeaway one for you. We're not going to do any exercises with it, but I wanted you to see how it works. So I've given you some functions in here, which I think in the future you'll be able to plug into all kinds of programming assignments. Something that takes an integer and outputs binary. So outputs the value in binary. I'll run this and let you see it. Something that sets or clears the 0th bit number, starting from 0 in any number. So the number that comes in, the reason it's a void is that I want it to work for char, int, unsigned, long, any integer type. So you have to specify how many bits there are in this number, how many bits there are in a number, right? The bit number, which bit, the Z bit. And then flag is whether I want the bit to be clear or not, cleared or set. So set it to 0 or set it to 1. And here's some cool bit manipulation stuff where I'm doing left shifting and knots and stuff like that. And I don't want to glaze you over. I would suggest just go and study this and look at it. And if you want to ask me questions through email or my office or whatever, or if you have a question now, that's fine. But I'm going to leave it at that unless you ask. And I'm giving you something that pretty prints binary and can also show you the hex values associated with it here. I'm going to run this in a minute. So there's lots of nasty bit manipulation stuff in here. And so in main, what I'm doing is setting n to be 1, showing you what it looks like in binary, touching individual bits, right? And yeah, and then outputting them. And so running this, you see something that looks like this. So 1 in binary is 1, 0, 0, 0. This is Little Indian, remember? It's on Intel. So the least significant bit is all the way on the side where you expect it to be the most significant bit. That's the fault of computer engineers. Under these values, you see the hex value. So when I set bit 2, I get 5, right? Because I've set Now the 1 bit, the 0 bit, and the 1 bit, so 2 to the 2 plus 2 to the 0 is 5 in decimal and 5 in hex. Now when I set the 12th bit, I get 4,101. See the bit is set here. When I set the 31st bit, it's way over here. You end up with a bigger value. Any questions?
I just don't like the reverse. We're doing it, so I was like,
Well, get used to it, man.
It's so much time to run from this.
ARM processors are also little.
The reason it's done, and I'm not gonna dig into the computer engineering too much, the reason it's done is regardless of the integer size, you have the smallest part of the integer in your hands when you first look at the very first memory address. You don't have to dig around to find where the integer bit is.
Which makes a lot of sense.
It does make a lot of sense. Because you're holding, you know, if you want the lowest, if you want the first byte of a char, int, unsigned long, anything, you're holding it by looking at the first byte. And you don't have to go digging through memory.
So kind of trying to make it all make sense.
Yeah.
That why in program 0, whenever we put the deadbeat,
Yeah.
thing, we had it
That is,
iterate backwards.
yeah, absolutely. All right, so you're about to do something on your own, just for a short time. I don't think it'll take that long. I'm gonna walk you through something that people in OS have seen this before. But the thing you're gonna do with it is different than the thing that you thought. If you're not in my OS class, then just disregard what I just said. I'm gonna show you how to read and sort and output integers. So you're gonna read a stream of integers, you're gonna sort them using a built-in sorting function. And you're gonna output them. And you guys, and I would suggest if you're not really strong in C, you know, collaborate and use one computer and type together, or 8 people do it all by yourself. We're not going to spend a huge amount of time because there's really fun stuff that I want to get to, but I want you to do some C programming on your own and not just listen to me going on and on. So here's something that reads an arbitrary number of integers, uses dynamic memory allocation, sorts, and then outputs the images. When you solve this, you need to hold on to it because a later assignment later in the night, when you're almost dead from exhaustion, you have to make some more changes to the thing you're going to do. So don't immediately delete it. Keep it in your hands. You're gonna type in my thing that's here, which is short, and you're gonna change it to do something else that I'll talk about in just a second. But first, understand what it does. So I'm prompting the user to enter a number of integers that they want to type in. Okay. I'm using a function called fgets, and there's a buff here that's of buff size +1. That's declared at the top. And I'm reading from standard in. So this reads one line of input that's carriage return, new line terminated. ATOI is ASCII to integer. It parses buff and gives me back an integer n. That's the number that the person typed as an integer instead of as a string. So ATOI takes a string and gives you an integer. I'm declaring an array dynamically. You see I have int star ints equals null. That's going to be an array, but there's no memory associated with it yet. It's not alias to anything. It's not pointing at anything useful except 0. No. Malloc is a way to dynamically allocate memory in C. And I'm saying this is the number of bytes I need. N, which is the value that just was typed in, times the size of one integer. Now I have a one-dimensional array that can hold n integers. That's exactly what I want. Then I'm looping from 0 to n-1, right? And telling the user to please input an integer. And I'm using fgets and ATOI again to read in ints of 0, ints of 1, ints of 2, ints of 3, up to n-1. Okay. Then I'm calling qsort. This is the built-in sorting function in C that works for any type. And it's the any type that makes it somewhat painful to deal. You'll see this in a minute. Then I'm just outputting the integers and that's it. Okay, but how does qsort work? I have to provide the base of the array I'm trying to sort, that's ints. I have to say how many elements there are. I have to say how big one element is. It's an integer, right? And I have to provide a comparison function. Because since this works for any type, qsort doesn't know how to compare the elements, and you have to specify that. It doesn't know whether they should be ascending, descending. It doesn't know what ordering you prefer. Okay. The best, if you're confused about C functions and you're using a reasonable machine, meaning not Windows, you could just use man to get man pages on this stuff. So if I do man qsort, you can see all the documentation for qsort. You can see the function prototype that's here, like that means all the parameters and stuff, and then a full explanation of everything that's there, everything there is to know about those sorting functions. And you can see that C also has built-in heap sort and merge sort and so forth. Qsort's typically the one people reach for, but if you study sorting and you know that your particular use case would be faster if you use merge sort or something, use one of the other ones. The idea is exactly the same, and you still have to write a comparison function, so you can't get away from that. Most people are like, which sort can I use without writing a comparison function? And the answer is none. So how does the comparison function work? Comparison function takes in 2 void pointers. That's because you don't know, qsort doesn't know what the type is. You have to write this comparison function for each new type. You have to take the void pointers and typecast them to the type of the thing that you're trying to sort. So here I'm taking P1 and P2 and typecasting them to be integer pointers. So they've been changed from void pointers, which means I don't know the type, to integer pointers. Now I dereference those guys and make them integers. So I don't want the pointers, I want what they're pointing at. So they're pointing at 2 of the elements that are in the array. S1 and S2 now are those elements. The function is supposed to work exactly like strcmp. If S1 is less than S2, you should return a negative number. That's what S1 minus S2 will do. If S1 is equal to S2, it should return 0. That's what S1 minus S2 will do. And if S1 is bigger than S2, it should return a positive number. And again, that's what S1 minus S2 will do. So this is an easy way of solving the problem. You just take the 2 things and subtract them. And that gives either negative or 0 or positive, just like strcmp. Does that make sense? Any questions?
Yeah. So you know, like a character pointer points to 1 byte and then 4. Does void have like a default before it gets?
No, that's why you can't dereference void.
Okay, so it just doesn't.
Right. It won't let you. The compiler will say that the type, basically the size of the type is. So that's why you have to do the typecast here. And so you can probably see that I can sort anything I want. I can sort strings, structures, anything, right? Does that make sense? Okay, so you're going to sort something now, right? And you're going to sort this. Take that example, type it in, right? Or agree that one of you will type and both of you work together or whatever. And you're going to solve this problem. You're going to make a type def at the top, struct car. So instead of reading integers, I want you to read in cars. That means reading in year, price, and make, and model, and color. So make, model, and color are strings, and year and price are unsigned integers. Read those in, sort them, and write them back out. Display them so I can see that they're in sorted order. And you're sorting by year and then price. And if you're stuck in any way, of course, just ask me and I'll tell you what to do, right? So your first step before bothering to sort is just figuring out how to read in cars. If you're sitting next to someone that's stuck, then swap places with someone that doesn't book stuff. And if you want hints, you just ask us, and there's a few of us here that can help. Anyone find this incredibly boring and you already know how to do it? No, seriously, help me. That'll help others. Anyone already know how to do it, you don't feel like you need to do it? Well, that's incredibly unhelpful. Because I was gonna let you help other people. You're bored, right? Alright, so, but can you be my helper?
Yes.
Okay, so if you're stuck, utterly stuck, we have a volunteer to help. First person to raise their hand gets. You're on standby. Yeah.
So do they have access to exercises or do they just make a new,
No, just
the
make a new
program?
files, but
Okay.
make sure you don't delete it, because you're gonna need to modify this later. Yeah. Anyone using Emacs?
Is it?
I do, so. It's not letting
You're
me.
trying to use Emacs? I feel like Emacs used to.
Oh,
People use Emacs get a free stick, and you're not getting a stick.
I'm trying to like,
I've used Emacs before. I've
I've seen you use it.
Yeah, but I'm using them right now, but I used it. Yeah.
Great if you don't get a stick.
It's free. Well, no, wait, no. I was mistaken. Emacs is a great operating system with the terrible.
Yeah,
Yeah.
exactly.
Yeah.
You'll get that.
Well.
You were so good. I mean, you did. Not very.
Stop. Stop.
Yikes. Okay, since that runs by your, app get installed. And then there's we do app install getting that or whatever.
I'll just go back up to you.
Yeah, just hit up till you get there. Okay. And then how are you doing? Okay, so.
Got it installed.
This is
Yeah.
actually.
There we go. Okay. Now it's done. And then, sort and stuff. I hate you.
Oh, wait.
Yeah, so
Or just basically. You're taking a new.
So then you want the name of your file, so it's just short.
This is a.
And then you can have, and then.
I don't have good accessibility. but it's sort of-
Oh, is this the cap? Oh, yeah. They should probably be using the Kali VM.
Okay, does Cali have Emacs pre-installed?
Yeah, but if don't change. Use Nano instead. But there's nothing to know though.
Yeah, Nano's pretty.
You just do Nano.
And I think all the commands are at the bottom anyway, aren't
Yeah,
they?
the commands are all at the bottom. It's just simple typing. So try that and see if it works.
Okay,
Take the name. .c. Yeah.
there we go. Just gonna follow.
Yeah, that's fine. You see that? Yeah, it couldn't be stupider. These are the only commands you have. Sorry, if you don't have your favorite editor, just use Nano. It's not much typing.
Died?
That's.
She just ate it when-
What happened?
You
updated?
What does it matter?
What do we do?
Mine tried to trigger an update earlier and I canceled it.
Why are they doing that?
I see mine is trying to get an update, but.
What happens if you don't?
How are we feeling? Is everybody coding away? Is anybody having any errors getting to an editor that they want to use?
Oh, but, I can give you some color, the guidance back. So you're, yeah. It's no fun.
Good? No?
So it is typing it so file, okay? Because it's.
So you are gonna be, yes,
Yeah, modify.
yeah.
Oh my lord, this is. So you're like.
When you provide a string and you get a.
Make you want to know.
What were the instructions?
I haven't looked at
I don't know.
Yeah, you need to talk to the computer, maybe sit with them and help with that.
Oh, Dr. Golden's the. I think it's Dr. Golden, what it calls it. The screen's on. Yeah,
Working.
okay, sweet. Well, yeah, oh yeah. I have those. Okay. Yeah. There we go.
I'm very slow by heart. No, I do not blame you. Also, I never learned how to switch type. Well, I learned how to switch type like finger taps and I'm typing. Also, type.
Is there anybody?
There's no one honest, but if you're still recording it, then she was.
Yeah, we're still recording.
Yeah. Now everyone knows. Anyway. Apparently. Oh, I'm sorry.
Yeah.
Well,
I agree.
No, no.
Sorry, I just like the word. My bad.
This video actually no, I should both these I think I like
Yes, like.
Yeah.
Oh, actually, you really love. Name is file.
No.
So, that's your. Yeah, yeah, yeah. That's. I didn't. Yes, yes. They're really having like. I'm pretty sure. I am not very so diverse. I'm not very. I don't know what you were, but. Yeah. Yeah.
Yeah.
I'm trying to get how are we feeling? I'll tell you. Yeah, no, it's all. There's an email inbox. The doc has to, like, basically. Yeah. Like, I need to. I need to. I really like that.
Oh.
Yeah. So you have to.
So what I
And then all the errors. Okay. This is wrong on.
Sorry, I should have like, maybe like that.
I believe you can write it.
Are you seeing your card?
Good that.
Are you seeing?
Yeah, and then it's also there are states like that, like what these guys have the
I'm taking a
If you just.
You like the.
Not really those things.
That's why.
Yeah.
That's probably that's
Did it die?
No, I obviously, you know.
Yeah, so standard balance is what I usually do. And the standard is what you're getting. Standard input, standard out. And or.
Really good at.
Just another.
Anything else over here?
Oh, yeah.
You doing? And. What a problem. I think it's yeah, you're about how stages.
Yeah, I saw.
Okay, all right, how are y'all doing? Okay, I think it's y'all in the middle, but how are y'all in the middle?
Yeah.
Good, thumbs up, yeah? I'm stealing.
Let's see that.
You know, ask, I need to find them. Yeah, one question, right? No, okay, so, let's see where we're at. Yeah, so you're on our property. You should type in the year and. Oh, yeah, it's this, right? Then that's based on that, right?
Sort by year.
Yeah, like it feels like. Just usually. You know.
So, ask me.
For all of the.
So like for parking.
So that means I can study for the. No.
Yes.
Okay, so you can file this?
Yeah.
Okay, so now you set it to file name. So now you just do dot file, cause that's the file name. So you're executing. Oh, not the dot. Dot is the source code, now you file it, so now it's just, the file name. Oh, now
I
you
got a
just
real
need-
question.
Yeah.
That's what I said. Well, no, it's easy, right? So it's. Another five.
I don't.
Oh, wait, yeah, you told me.
Oh. Oh, I am taking. Along with that.
One of the. Like. No, I forgot. Is everyone getting kind of close to being done? Modifying for this? Yes, no.
We're not gonna get all of it. There
Oh,
is
yeah.
one. Yeah, it's destroying me too.
Yeah. Oh, yeah, no, I think we're all gonna do it, guys.
Weird, yeah.
And I like confirmed your plan. And they say. Like I said, I think it's chill. And everyone's just gathering.
Yeah. Men's, yeah, third round, my suffer is thing.
Girl. What's up? Is this free? I think he's talking about.
Yeah.
Is this free? And is that what he's talking about? So. Anyone else need answers to questions?
What is life?
Stop. 42.
That's the median of life.
So I have a.
I know.
I'm pretty sure I know exactly what to get.
So I'll.
What's up?
You know, I have, be sure you know which one that actually. You can just plan it
Yeah, so you have to. Okay, so.
That's all.
Okay, so it's to be.
Are we? We're gonna be reading from. No, it's like managers, you just type in the data for the cars. Oh, so we get to create. Okay, like the input problem. Yeah, so I'll show you mine runs. I thought we were gonna be reading. So this is like.
Oh, yeah.
Whenever I do this. Look, I'm gonna remove the assignment.
That's fine.
Plug in the.
Or is that? It's.
Sorry, I couldn't make sure I'm not.
Yay.
talking. Oops, okay. I hope y'all don't mind the top of my head.
I'm on your.
Okay. Anyway, so. Look, if we talk about long, you know, I'm trying to figure out, there's some stuff there, and like, I'm not seeing any other instances of this thing,
integer array of like 5 plus something, and then there's negative.
I'm sorry, so that's what.
So I believe that in
This could be.
Because you're, when you say you want that there and take it off, right? Are you actually? Oh,
Alright, so guys, that's what I would like to see. If you're stuck and can't get there, then let us know.
Yeah, questions though.
So, yes, I filled this one. I'll try to get to it.
Let me know what it is. And there's this array of like 5 plus something, but it's not.
That's because I was doing something with the example last time. I forgot to just the A, I think is in there too. You know.
Oh, yeah.
I was just a random thing.
it's printing out this thing.
For, I know for the end, it was just kind of like sort of and I guess the same, but how do I say this? For when they are the same.
So with everything, good, it's the FP.
That's what I was thinking.
And then go
Less than zero, or if it's, I think equal to zero.
Right, so one out here, the same, less than 0, then the first is smaller.
So maybe.
Right, yeah.
Okay, what are you
So you whatever, but you'll have more comparable.
I do believe.
Oh, so I need to write it. I did not
So
write
it's
it.
kind of like your, it's kind of like the ends, if there's maximum key and like there's what's. You'll do that, I ran instead of, I don't think you're gonna be the different outline parts, then I can. So you'll be comparing the year and the price, and you're not comparing the. That maybe so.
Yeah.
And also I write. And I like referencing that kind of information, so my course had a degree allocated for, specifically for that. So. Sorry.
No.
How is that my, how, what could be happening here that means there's no better being outdated or being expanded? My first thought is that.
I mean, I'm not doing that right now. I'll do it.
I'm never, you never.
They get passive vision, so it's not gonna cause anything.
But you know what? I. Yeah. Just like test it out and see how things can go from there. I'm gonna let you lead yourself through that. Sorry, y'all, if I'm not sure this is a little bit. There we go. My big head contains many more. Any questions? I don't know, I think that's fine.
having any trouble with the comparison function or anything else?
Yeah, comparison function, are we passing by like 4 arguments instead of, no? Okay.
So I'm gonna help you make this comparison function just this time. Maybe just learn from me. Watch. The assignment is still at the top here. But this is actual code. for the comparison function.
Like this, when I had it. Oh, no. I usually use it. I didn't.
Sorry, it resolution.
We tried. Yeah.
I think your laptop specifically is kind of special.
I connected my own internet, so that I wouldn't have to link to.
That's the comparison function for free.
Yeah, my.
Well, that would round out those.
If you need to see more things, just let me know, and I'll show you.
I don't know if you and then just like try. Yeah. That's how it works.
Oh, wait.
So the reason this works this way is Qtern always passes 2 pointers to elements it wants you to compare. And they can be any type. So you have to write a custom comparison function each time.
Control Z doesn't work. Is what we have.
I was gonna separately compare, I don't know what else. I don't know, never mind.
Yeah, you're supposed to sort by year and then price. So if
Yeah.
year's the same, you need to fall back on price.
Yeah, that is one of the.
Apparently there's ways. No, I'm seeing like.
Oh, I'm not doing.
Why?
It's all good.
They're not supposed to.
Is there any way that in this class, random question that you may show us how to do priority?
Oh, maybe.
Oh. So you like. Yeah, no, I think so you could probably take some. Again.
Number.
So it could be VPT, that, no, space for it. Tell us.
It's hard, I hear. Because it's, the bar.
It's listed in, it's a song. I get you.
Yeah.
That's why, that's, so you have to.
Yeah. I think they say.
How do you roll with these?
Now it's.
Yes, so that's the thing.
We have to actually.
Like,
Which is.
controls.
You can't.
But.
Yeah, control shift.
So wait, so get back to like your.
If you're wondering what this two point view sort of looks like, that sort of model looks like that, obviously it is fine. It looks much like the other one, except that you're not using cars instead of it.
So you have. Yeah.
Anyone stuck on reading this stuff in? You're okay? Stuck on reading stuff in?
Yeah, I just. She was helping. I think I might have figured out part out.
But I'm just kind of- I can bring you those pieces to you guys, right?
Oh, yeah, yeah.
Like
Did you do it?
Oh.
It's the same exact issue I had last time. Oh, smell. Yeah.
I have to do this a little bit because of time, so I have to push you a little bit. So the code that you see on the right hand side is code for entering the number of cars. Entering the number of cars and then entering the information for everyone.
Oh, yeah.
Is control C.
It sort of comes right after that.
Honestly.
I was so close.
Value. Okay. Is it?
It's fine. It's not, no, I just want the files. It's just.
Okay. So here, it was on. Like Apple and. What's that hex? Laptop sticker? The C0. Oh, coffee. It's coffee. Oh. It took me 15 minutes. Budget max sticker, yeah, X0 X.
Oh.
Yeah. And Steve, I wonder what color this is. I don't know. I like dead beef. I'll have to have dead beef.
Yeah, no,
It's just bring it, like. Yeah, no, I missed like the first hour. Yeah, yeah, right.
Oh. No.
Oh,
Stuff on the other part, the sides entering stuff. You have to be honest.
It was totally done, just like waiting for a video. Hands up, no, nobody, okay, so is everybody stuck somewhere? We just kind of run it,
What are you stuck on? What are you doing that you're stuck? You're stuck.
raise your hand.
That's fair.
To compare, okay.
So Q sort always gives you pointers to two elements. And the idea is that it's considering two elements in the array and trying to figure out where to put them, like which one's greater than the other. So it always passes you two pointers and it's always a void pointer. So you're always gonna have to pass the type that you know is in the array, so that's car. And then we're dereferencing the car pointers to get an actual car, not a pointer to a car, but a car. And then S1 dot year is the year of the car, and S1 dot price and S2 dot price, those are the prices of the car. So, yeah. So the very first thing, an experienced C programmer probably wouldn't write it in this long form, but I'm doing this so that it may make more sense. So. You always get 2 point pointers. So this is casting the 2 point pointers to the bar stars. So I'm not to our bar star pointers now. And then I'm dereferencing to not have a car star pointer and actual car. So the car star pointer is pointing at the box, but I want the box that has the years. And then once I have that, I can just subtract the years to see if that's 0 or not. The pointers are hard.
What part of that? Stuff on the right.
This reads in all the information about the box. It's letting you see it. So it starts here, it starts right at the beginning of the thing. This is so all of, once this is complete, you have all the car information ready. Question? Yeah. Let me see your phone. And here it's clear. This thing. It's kind of defined. Yes.
Yeah.
Yeah, probably.
Do you have a whole board?
Anyone else?
Yeah, what do y'all have on here? I'm trying to figure out how to copy paste it.
I'm not trying to get
Control shift, C, control shift. No, in Nano,
Really,
it's.
yeah.
In Nano.
It shows M-6, but I don't know what to trigger that.
Huh?
It's saying like M-6.
In
like,
Nano,
how-
in Nano, I just do, I cut, so control K and then. So I cut it and then I replace it and then I just.
Yes, so the idea is that if you look at the like enterprise, enter year, enter make, there's no new line. If you don't place a new line, you're not guaranteed that the output will appear as easy. But what I wanted is for the input to look sort of neat, where when I'm reading it, it's on the same line. So by leaving the new line out, I'll start typing on the same line as I see it. The F flush just make sure that the enterprise year actually are out on the screen. You have. Yeah, E1 is this is a pointer.
Yeah.
I think so. If you're gonna do it. Yeah, but this is applying to.
Yeah, for sure.
It's applying to this. You need more parentheses.
AI stuff.
You need to put parentheses around.
AI stuff that is by the side.
Yeah.
No, I'm just.
Oh, you might as well.
It's the size of the entire place.
Better not the.
Oh,
No, size of cars. Everything, year, price, make, model. Yeah, the reason you don't need to know this is that you just use size of it. It calculates the entire size.
It's okay.
Yeah.
Oh, I.
You do all of that.
Alright, I'm gonna reveal a little bit more for you guys, and you tell me if you think that it doesn't. So the part that you were looking at on the right is now gonna be. This is, I'm gonna make it a little small, sorry about that, it's not readable. That's all the way down to the Q sort, then outputting the cars just looks like that. Okay, it's a little small, but put your readers on.
Oh.
So you're seeing some duplication, use the line numbers to see that, but that's the whole thing.
Yeah.
Oh.
Is this a bridge? But I would like.
It is, that's.
Every.
Yeah, no, I'm just thinking that I'm gonna answer you correctly, and the answer is yes. If you do, and there's whatever, plus, then your FES, there are. It'll be good. I'll put on there were a few people, and then you're like,
We can mix.
yeah, yeah. Nothing, I love it, I still.
Oh, no, that's not a new stuff, which basically.
There we go.
Oh.
They do like why
So I would like to.
now. So you should be able to do.
Yeah.
You can do like the. Or like.
Here.
And then go down to level spaces. Lowercase paste it after the cursor.
Yeah.
So just be lots to do, so lowercase p paste it after the cursor. And then uppercase it after the piece. There you go, I got her. I love that. So I have to have the. Anytime I use this.
Yeah.
Huh? Save and escape.
Okay, press escape.
Colon. Or take. And
What bars did you?
like, I thought, I want.
Yeah.
I literally, this is like brush. It's like.
Oh.
When you are. I couldn't live without. And also change.
Yeah.
So how we feeling? Is anybody still stuck on anything? Good, so everybody's done.
Just ask if we're progressing.
Is there somewhere in between stuck and done?
I'm progressing.
Maybe, yeah, okay. Do you have your hand up because you're in between stuck and done, or do you have one?
I just don't know if I have it.
Run it and see if it works.
I'm running it. I need to see the exercise and see what's sorted.
Isn't it years?
Yeah, so I put it on this side.
You just visualize that.
It should be years and hours.
Yeah. I totally get that. I really do.
Is that just? My favorite.
Oh.
Yeah,
Do you speak?
that's what, that's just. I entered this class last year, and I was not.
Yeah.
Yeah, like, I'm not.
Like sit in.
Yeah, like, I didn't sit in for the whole semester. After a break. Now, I'm not gonna be.
Yeah. Yeah, I had it for OS twice and then for.
Yeah.
Yes, it's not. Or the. Yes, yeah. You do know. What?
So, guys, just an advertisement for the rest of the pack. It's never possible to get through that. The idea is that we do a few things in here and you have some stuff to take away. If you look deeper into the pack, you find UDP and TCP networking, so you can do like network programming in C. There's game programming, how to accept input without waiting for returns. You can do like action games and whatever you want. And if you have questions about anything that's in there, just stop by and say hi.
Does everybody know where Dr. Bone's office is?
Yes.
Yeah,
Far away.
very far. It's right around.
Yeah, it's right around.
So, started that year at the microprint, right?
Yeah.
So it was your, highest year. Well, you know, 3 cycles. And so, it is sort of. But, for some reason, it's giving me it's one of those like little silent.
Oh, yes.
So small.
Sorry, with the laptop, where the projector is. And then, because I think the people who were on it earlier popped off, the part of it being the.
I'm really just on roll.
That would be us.
Yeah.
Yeah.
You could also say it's the next summer.
I don't know, like,
Just that.
I'm getting, yeah, I didn't tell you, I was saying there.
Like, at the bar, you get more organic, you're saying that that's better than it used to be.
Yeah, because the old C didn't have time, so this whole time would have been struck car and stuff inside. And every time I declare one, it's had to say struck car single.
So you would.
Now, yeah, without,
I did that.
yeah, so now with type they're doing, they're creating a new name for the type struck car.
It's like saying, car, you can just.
Yeah. Okay, exactly. And now I can just do this so much better.
Yeah. What was the last one?
Oh, the latest thing I see is
It works.
Sorry, I'm sorry.
It's story. It doesn't.
Windows also. Windows also.
If you make that.
Wait. The new thing. Yeah, I like.
It's also. And then.
Yeah.
I think that's what. Download all the song. Then when I click on your.
I'm very excited.
Oh, it's already 8:30.
They used to do that. They used to say,
Really, you got 8 more hours.
Alright, y'all ready? So you know what, maybe we should do like, instead of doing.
They just do, they just see marathon.
I see, okay, wait.
Do you wanna give
Now
away
you're
your
speaking.
entire
Yeah, when it entirely.
No, you're talking facts, SSL is behind this.
You know what, that's a cell can host.
Yeah.
I don't wanna spend an entire weekend.
That's what
I would.
We suspend the patient saying a collaboration.
Yeah.
Someone else should be the patient saying a collaboration.
I'm gonna be.
Yes, thank you.
Let's say real.
Be ready to next semester, email you on Monday at 12.
Very
I need a practice problem every week. Every week. And I will turn it into by Friday.
You know, your first assignment would be is to write a script to send an email for you.
I should. I will write it. And I will come back.
I'm usually there.
What you like? And you
I
just
present
see the
next week, because,
I know. I feel like so confident.
so I can't. The first assignment, so, but yeah, I figured that's what you were talking about, was like someone on the farm. Yeah, what is, it's.
Well, either or.
Operating system. But I don't know if I should say that.
She's
So what
using
are you
it.
gonna do?
Oh, we're trying to coordinate.
Does Dr. Chen coordinate?
But,
Oh, Sean Eastfield does his program.
Yeah.
Which is part of a.
Dr. Chen also is like, oh,
Yeah.
Yeah, which is best.
Who knows what?
Chen.
Then why would you suggest I do this?
You would, it was. The option that you can do it.
I am not. You must have option in WiCS. And I was like, no, put me in C plus plus.
Yeah, I think.
Yeah.
I don't know that.
Hello, we can't reach you.
Yes.
Oh, that's exciting. What was that? So it was like you breathe twice. Did you breathe something twice by mistake? Let's see, I'm just like, use this away so I can actually see what you're doing. Possibly. Maybe. Okay. Does it have a,
So much, like, do you not like having to travel from here, get to with like that small section of traffic? It
It's so long to get the rock started. It'll be 5 years.
Oh.
I don't.
Yeah. Just use the fork.
oh, yeah, like, yeah, twice, you're right, I keep on forgetting about.
I prefer it on the street, so like. I don't know. I thought that it was getting like, this building to like redo it like they do here.
Yeah.
You see the.
I'm gonna call him.
Where am I at? Wait, no, let's do it. I'm doing things like this. We're gonna look at. I just might have to do other things.
Maybe.
It does. It's mainly sidewalks.
I mean, if it worked over.
It's.
See too small.
That's what I thought. I thought you had received the money. Like,
No, we have money.
But the
It's all sidewalks.
So.
It's awesome.
well, it's just nice to be there on the outside. Okay, I did that.
Oh. Oh, so it's on that, so it does not. Okay.
Oh, yeah, working program.
Oh, I forgot to.
It's so scary. Yeah.
You're right.
I will be. What do you think?
Yeah.
It would be better if that's.
Okay.
I can act that. Yes, like even more national. I could even more of a thing.
Oh, it's, yeah.
Yeah,
there you
so
go.
something like that. Yeah. And from the president.
That's.
Just reach out to me.
Yeah, pretty much. All right, let me slide out of the way, so the professor is here.
It's a very dangerous lab.
It is.
It's gonna be rebuilt, so.
That's some of the information is going to done. With the people. So it's all online for.
Yes.
I started not being able to.
I know.